All right, folks, I guess half the class is still out doing the project, so welcome those of you who made it here, and congratulations on finishing. Midterm 1 is coming up on Monday, so please don't forget to show up and take the midterm. Very bad news if you don't. It'll be right here in class, replacing Monday's class, 4 p.m., this room. Unless you are in the Disabled Students Program and the university has requested extra time on your behalf, in which case your exam will be in 508 Soda Hall, and it will start at the same time as everybody else's. There is a review session the TAs are putting on tomorrow. That will be in 306 Soda Hall. They will find a way to prop open the third floor entrance to Soda so that you can get in there during the review session. And that'll be from 5 to 7 p.m. tomorrow. So hopefully that'll help you all out. And by the way, the next homework is up for those of you who want to get right into it. Yay! The midterm will be open book and open notes. You can bring your paper goods with you, as many as you want, and have them there to help you out. But electronic devices are not allowed on your person. And we're very serious about this. If I catch you with a cell phone on your person in the middle of the exam, I'll give you a 0 on the exam. So please either leave them at home, or when you arrive, come up to the stage and leave all your electronics on this table or on the stage, and make sure it's there throughout the exam. Also, if you do bring a cell phone and leave it here, please make sure it's turned off. Or I will answer it and make a new friend. And they won't like you anymore because they'll be spending all their time with me. Today's lecture is on exceptions. You've seen exceptions, but mostly you've been annoyed by them so far. They can be useful, though. So when a runtime error occurs in Java, the Java virtual machine throws an exception. Which kind of sounds like throwing a fit, and it's the basic same idea. And usually the result is an error message, and error messages which a lot of you find incomprehensible, but should learn to try to read those error messages, because they actually do have a lot of useful information in them. Now, one of the interesting things about Java exceptions is it's not just the program blowing up, but an exception in Java is actually an object. Pardon me. And what's even more interesting is that if you're so inclined, you can prevent the error by catching the exception in your code. And that stops the error message from printing, and it stops your program from terminating, usually. And since exceptions are objects, after you catch one, you can actually examine it and look and see what's inside it. So why do we have this? What is the purpose of all of this? There's several different purposes, and I'll tell you about a few of them. The simplest one is it gives you a way to survive errors that would normally take a program out, but if you're ready for that error to happen, then maybe you can survive it. The classic error is, suppose you write a program that opens a file on the disk and reads stuff from the file and does something with it. Well, if the file's not there, or if your disk drive is crashing and therefore you can't read the file, then maybe you just want the program to crash because you can't do the thing anyway. But in some programs, you want the program to keep running and survive something like a disk crash. You know, if you're writing an operating system, you don't want the whole computer to go down just because one disk isn't working. So this gives us a way to survive a disk error, and perhaps even handle the disk error in a different way than we normally would handle reading a disk. can't bear to erase Spidey. So there's your classic example. Try to open a file that doesn't exist, or that's protected so you just can't open it. All right. If you're not allowed to read that file or it doesn't exist, Java will go and throw an exception. And you can catch the exception, print an error message, and continue. So here's a simple code example of that. If you want to be able to catch an exception, then you have to put the code that might throw the exception into what is called a try clause. So here's the try clause, and inside I have code that does risky things like opening a file. So if you're wondering, this file actually does not exist. So there we go. Inside a try clause are two dangerous things. Opening a file, well, it might cause an exception if the file doesn't exist or if the protections are set so that you can't read it. The read statement could throw an exception even if the first statement works, because maybe there's a bad sector on your disk drive and that track of the disk isn't readable anymore. So these can throw two different kinds of exceptions. So in order to plan for that, we follow the try clause with associated catch clauses that catch different types of exceptions. So the first one might throw a file not found exception. And here's how we catch it. We write a catch clause, and inside the catch clause, we put code that says what we want to do if this exception gets thrown, and we catch it. So in this case, I'll just whine about the fact that I couldn't open the file. Now, one thing I want to point out about this catch clause here is that what's in here is not just the name of an exception. It's actually a variable declaration. So E1 here is a variable that you are declaring to be of static type file not found exception right now. So if a file not found exception does get thrown, then not only will this catch clause execute, but inside this catch clause, you will have a variable called E1, which actually references the exception object. And so you can call methods on that exception object if you want to. And it can do things like store a string that explains what happened. Now, this only catches one type of exception, but there are other things that can go wrong as well. Maybe the file is found, but you get some other kind of exception, like if your hard drive crashes while you're trying to read a bad sector or something, then you'll get a different kind of exception. And in that case, you'll want to do something different. In this case, what we're going to do is we're just going to close the file. This is a very common thing you see, is that one of the purposes of catch clauses is to close files and take care of other loose ends that are left open if you can't complete whatever task you were trying to do. So again, let's write down what this code does. It does three things. It executes the code inside the try braces, at least up to the point where an exception gets thrown, and then it stops trying to execute that code. If an exception gets thrown, well, no, actually, let's do the other one first. If the try code executes normally and does not throw any exceptions, then we just skip all the catch clauses. The catch clauses never get executed if an exception doesn't get thrown. But if an exception does get thrown, then we immediately stop whatever we're doing in the try. So do not attempt to finish. So instead of finishing the try code, we look for an exception handler, or a catch clause, that we can execute instead. And if there's more than one catch clause that matches, we jump to the first one that matches the type of exception we're throwing. And then we execute that catch clause. Now, what do I mean by matches? By that, I mean that the actual exception object that got thrown is in the same class or a subclass of the static type of the catch clause. So for example, there are a lot of different kinds of I/O exception. I/O exception has a bunch of different subclasses. You might have a bad discrete exception or something like that. I don't remember what the names are exactly. But if you have an object which is called bad discrete exception and is a subclass of I/O exception, then this clause can catch that. Question?
So like we have just a generic like exception test?
Yes. Well, if you want to do that, yes, you can. So certainly you can just write catch exception, and that will catch every kind of exception. The other thing you can do is you can do catch exception, but you can have a bunch of other types of exception before that in catch clauses of their own. So, for instance, file not found exception here is actually a subclass of I/O exception. So if this try code throws a file not found exception, then both these catch clauses match. So Java just picks the first one that matches.
So that is the generic one, just exception.
The generic one is exception for the most part. There's actually an even more generic one, which I'll talk about briefly at the end of the class, that you would not want to catch very often, though. Other questions? Yes? Can you define an exception object? Yeah. You can define your own exceptions, and I'll show you shortly why you would want to do your own subclass of exception. And you can also just declare an exception object and create one anytime you want. So I'll show you when and why you would want to do that as well. All right. Other questions? one more thing to point out here. These little bits of code, like this bit of code here inside the catch clause, or this bit of code inside another catch clause, there's a name for these. They're called exception handlers. Which is actually a name that predates languages having exceptions built into them like this. And I want to add one little extra point to the end of C here, which is that when the catch clause finishes executing, Java jumps. The last thing that Java does is it jumps to the code immediately after all the catch clauses. That's how part C ends. So if we executed this exception handler, then when this exception handler is done, we immediately jump down to whatever code is down here. Again, I guess I should write down, because it's important, that only the first matching catch clause is executed, and not the others. And finally, you do not need a catch clause for every exception that can occur. You are allowed to just let some kinds of exceptions propagate through and print out an error message. So here's a second reason why you might want to use exceptions. Basically, when you're writing code that does something complicated, and suddenly in the midst of doing that, you realize you're not going to be able to finish because something very important is missing, then you can use it to get out of a whole pile of complicated methods that are sitting on the stack. And so here's how that works. First of all, to take advantage of this capability, you actually roll your own exception and throw your own exception. Why would you want to throw your own exception? Well, one example where this might come up a lot is writing a parser. A parser is a program that walks through a computer program, like your Java code, and actually figures out what it all means so that you can go ahead and compile it. Now, parsers are very complicated because there are different procedures, methods, for parsing a method, parsing a class, parsing an expression, parsing part of an expression. And all of these things are recursive. An expression can contain sub-expressions, which can contain sub-expressions, so the expression parser calls itself recursively. So you can wind up with a stack full of dozens of recursive calls between different parser methods and each other. And then suppose that you're a program, you're parsing some student's Java code, and the student accidentally erased the last 20 lines of their file. Oops. And so you're very deep inside a class, inside a method, inside a bunch of curly braces, inside an expression, and all of a sudden, bam, the file ends. Well, what do you do next, you know? You're not going to be able to finish parsing that expression, that method, that class. You just want to get out and stop right there. And so that's where throwing an exception can be really useful, because what throwing an exception allows you to do is pile your way out of loops, up many levels on the stack all at once. So here's how we do that. First, define your own exception. Let's call it a parser exception. And if you want it to act like an exception, it has to extend some kind of exception that already exists. We'll just go for the most general kind of exception. So there, I've got my own exception. And what is the purpose of creating a parser exception that extends exception but doesn't add anything new? It is to be distinguishable from other kinds of exceptions. That way, I can catch a parser exception without accidentally catching other types of exceptions, null pointer exceptions and whatnot as well. Do you have a question? Okay. All right. So here's some sense of what parser code looks like. I've got an expression parser, a method named parseExpression. And parseExpression returns a parse tree, which is a tree representation of what your Java program looks like. And when I declare it, I declare that it throws a parser exception. Using the throws keyword. Now, if a method can throw certain types of exceptions, you have to declare that that method can throw that type of exception. So you need the throws keyword to do that, or the compiler won't let you compile it. Then maybe we've got a bunch of loops and stuff here. So a bunch of lines of code I've condensed down. And then at some point, we discover that something has gone very wrong. Like the file has run out or in the middle of the expression or something. So we say, well, don't know what else to do, just going to throw a parser exception and get all of this parsing code off of the stack. And so Java has a throw keyword, not to be confused with a throws keyword, that actually throws an exception. And then, lots more code here. Returns a parse tree. So that's the kind of thing you might see. Now, you might ask, how is a throw statement different from a return statement? Well, first of all, you don't have to return anything, which simplifies your thinking if you don't actually have anything to return. Like in this case, we didn't manage to finish building a parse tree, so we have nothing to return. The other difference is that a return statement can only go one method down the stack. An exception can go a lot of methods down the stack. In fact, a method flies down the stack either until an exception flies down the stack either until some method catches that exception, or it gets all the way to the bottom and your program terminates with the error messages that you're accustomed to seeing when you have a null pointer or an array index out of bounds. Any questions about any of this? Yes?
If you have multiple independent exceptions,
Uh-huh.
can you like add it to your constructor?
To your constructor? Well, you can have a method that throws multiple types of exceptions. So I can say throws parser exception, some other kind of exception. And I can make a whole list of exceptions a method can throw, separated by commas. I can only create one exception, construct one exception at a time. Well, let me rephrase that. A constructor constructs one type of exception. Does that answer your question? Okay. Something's going wrong with this board. So I'm going to write some more parse tree code just to give you a sense of several other things that might happen. So for instance, the parse method might be what's calling the parse expression method, and it might be able to throw several different kinds of exceptions. And so there we have more loops and more code. And somewhere in here, this method's calling that one. And maybe at the bottom I have a method called compile, whose job is to compile your Java code. All right, so what the compiler does is it has a try clause inside of which it parses your entire Java file and then converts it all to bytecode. And that's what a compiler does at the top level. And then if something goes wrong, instead of allowing the program to crash, we can catch those exceptions. Maybe we'll let the dumb code exception crash the program, but the parser exception, we don't want to let that crash the program, for instance. So then when you're running this program, your stack might look like this. You've got compile near the bottom, on top of main maybe. Then you've got parse. Then you've got parse expression. And then you need parse expression. Typically in compilers, the expression parser often calls itself recursively, because expressions can contain sub-expressions. And suppose this throws an exception. So the throw command throws a parser exception. Then what happens is Java says, OK, that exception's not caught inside this method, so this method's off the stack. Does the code in here catch that exception? Nope. This method's off the stack. Does the code in here catch it? Nope. Does the code in here catch it? Yes, it does. So this parse is inside this try clause, and here's a catch clause that catches that exception. So by doing a throw, we've gotten our execution back to the main compiler. We've gotten rid of all of these methods that are no longer useful to us because There's nothing left to parse. And the compiler still has control, so it can do something else, like print an error message, go on and try to compile a different file, even though your one file couldn't be compiled, or whatever you think is the appropriate way of handling an error. Any questions about this? Okay, one thing you might have noticed is that a lot of you have seen a null pointer exception. A lot of you have seen an array index out of bounds exception. But you probably don't remember ever declaring a procedure to throws a array index out of bounds exception or a null pointer exception. So how did that happen? Well, Java distinguishes between two different kinds of exceptions. They're called checked and unchecked. Checked are the ones you have to declare. Unchecked are the ones you don't have to declare. And, well, here's the true hierarchy of exceptions in Java. Actually, all exceptions are a subclass of throwable. Throwable is actually the superclass of exception. And there are two and only two kinds of throwables, as far as I know. They're what are called exceptions that we've been talking about. And you can also throw an error, although you, in general, would never have a reason to throw an error. Errors are kind of like exceptions, only they're more serious. Errors are places where the compiler goes wrong, and there's almost certainly no chance of recovering from it. So a typical error is running out of memory or stack space. Now, you actually can catch an error. You can write catch code to catch an error. Usually, you wouldn't want to, and even if you do, there's no guarantee of success. If your program is screwed up because you've run out of memory, then catching an error isn't going to make more memory magically appear. Probably your program's just going to re-crash all over again. But now exceptions come in several types. There's a subclass called runtime exception. And it has a whole bunch of subclasses, which include the null pointer exceptions and the array index out of bounds exceptions that you guys have become familiar with through hard experience. And then there are a bunch of other types of exceptions that include things like I/O exceptions, for instance, which, actually, is I/O exception checked? I don't remember. I better not do that. You'll have to look that up if you want to know. Parser exception is definitely unchecked. Or sorry, it's definitely checked, pardon me. The unchecked exceptions are runtime exception and all its subclasses, and error and all its subclasses. So anything that's error or a subclass, or runtime exception or a subclass, is unchecked. And that means they do not need a throws declaration. So any method can throw a null pointer exception without having to declare it. And the reason for that is that runtime exceptions and errors are things that can happen in almost any Java code you write, so it just wouldn't make sense to have to declare them all the time. It would be a nuisance. But other kinds of exceptions that don't happen except under unusual circumstances, those are worth declaring so that people who are writing code that uses your library that can throw a special kind of exception, like a parser exception, know that that exception can be thrown and that they need to think about how to deal with that if that happens. Now, when a method throws a checked exception, or calls a method that can throw a checked exception, it has two choices. The two choices are it can catch the exception, so that the exception cannot propagate outside of the calling method. Or you could let it propagate through the calling method, but in that case you have to declare that you can throw that exception too. And that is why the parse code declares that it throws a parser exception, option 2. But the compile code does not declare that it throws a parser exception because it always catches it, option 1. So I guess it still needs to declare the dumb code exception or else catch it. So are there any questions about that? Yeah?
What if an exception is not declared but also not checked?
Then the compiler will tell you that it refuses to compile the code. So if you don't follow these rules with a checked exception, the compiler won't let you compile it. And that's actually kind of handy because actually the best way to figure out what throws clause you need to declare is to just not declare one and compile your code and let the compiler tell you which exceptions you need to catch or declare. So the compiler will figure that out for you if you're too lazy to figure it out yourself. No big deal. Yes?
Say like you have an exception, you catch it in the catch clause. What if there's an exception there?
In the catch clause, catch clauses can throw exceptions, and those exceptions go on, meaning they're not caught themselves unless they're inside another try clause. In fact, I will talk about that on Wednesday's lecture, so I will go over the rules for what happens if a catch clause throws an exception on Wednesday. So you'll get to see more of this answer to your question in detail. Other questions? Well, good luck on Monday's midterm.